Okay, for this example, you have a steam generator that uses or burns fuel oil with a chemical analysis or the ultimate analysis, in other words, of this fuel oil. And then you have a theoretical air given, or in other words, the excess air is 25%. Then the pressure of the flue gas is given, and also the molecular weight of the flue gas is given. So we want to know the partial pressure of the stock gas to avoid condensation. So for us to find that out, we want to have the no, volumetric analysis of the byproducts or the flue gas or the products of combustion. So to do that, we can find the mass of each of the components or the compounds. Then after that, we can convert that into its volumetric, no, analysis. So the first thing you should do usually is to find the mass of the theoretical air. No? So the mass of the theoretical air is you have 11.5 C plus 34.5 H minus O over 8, and then plus 4.32 S. Now the given here, you have 11.5 C. So C here is 85. Sorry, it should be in decimal places. 85.3 plus 34.5. H is 14.1. Sorry, 14, 14.1 minus, so we don't have an oxygen, so this will be just 0. So minus 0 over 8. This is just 0, no? And then you have plus 4.32, 0.5, 0.05. Oh, this is 0.005, no? Okay. So the mass of the theoretical air, or the air fuel ratio of theoretical air, is um, 34.5. So you have 14.70. 14.70, the unit is kilogram of air per, not air, air per kilogram of fuel. So the actual air will be just 14.7 multiplied by 1 plus 0 or 125, no, or 1.25. So 25% is excess air. So we just multiply this by 1.25. You have 18.37. So kilogram of air per kilogram of fuel. Now we can start with finding the CO2. So the mass of the CO2. So what is this? Is this a complete, incomplete combustion? Theoretical. So we have an excess, it is either complete or incomplete. So if it is not given, surely this will be just complete, no? So we can find the MCO2 for just to remind you, no, fuel oil is also a liquid fuel and usually don't have a carbon residue or a carbon refuse. So usually fuel or liquids usually are fully combusted, no? So anyways, you have 44 over 12 C, no, for complete combustion. So C here is 0.853. So you can find the mass of the CO2. For CO, we don't have a CO, no? But what we do have is it's usually the next one, oxygen. Oh. So oxygen here is the mass of the theoretical air times the excess air, and then you have um 0.231 pala, no? So 0.231 mass of the theoretical air and then excess air. Plus you have here 16 for incomplete combustion lang pala to, no? So it should be for complete combustion na ito lang nga pala yung ilalagay natin. So this will be equal to 0.231 mass of the theoretical air is 14.7, and then the excess is 0.25. Okay, you can find that later. And then for the mass of the vapor or the nitrogen first, no? So for the nitrogen, you have 0.769, the mass of the actual air, okay, and then plus N2, no, of the fuel. So what you have here, the actual air is, you have 18.73 or 37, and then the nitrogen of the fuel is 0.1, ano? So 0.00, sorry, 001. Oh, so this is in percent, no, don't get confused. This is in percent, so you have to divide this by 100. So solving for that, we can solve for that later. And then lastly, we have still sulfur. So second to the last, you have the water vapor. You have 9H, you know, and then you have the humidity, mass of the actual air, and then plus the moisture. Also, this since this is a liquid, we don't have moisture, no, and we only have dry air, no, so zero then again. So therefore, this will be just 9H, so 9 times 0.141. Okay, and then you have the mass of the sulfur dioxide. So we have sulfur here, so sulfur dioxide. This will be just 2s, no? So 2s, which is just 2 times 0 point. So divide this by 100, 0.005. Okay, so we can calculate everything together. So you have 44 over 12. Okay, this is 3.127 3.128. So kilogram of CO2 per kilogram of fuel. What's next? So 0.231, mass of theoretical air, so 14.7 times excess air. So 8489, 0.8489, no? So take note of this. So this is in O2 per fuel, no? Kilogram O2 per kilogram fuel. Then you have the hydrogen. So the nitrogen, 0.769 times 18.37 plus 0.001. So that will be 14.13. So 14.13 kilogram of N2 per kilogram of fuel. Then for H2O, so 9 times 0.141. Okay, 1269. 1.269 kilogram H2O per kilogram of fuel. So sulfur dioxide, so 2 times 0.005. 0.000 lang. Yes. Yes, 0.005. So 0.01 kilogram of SO2 per kilogram of fuel. Okay, so let me just check this. Okay, just verifying if we are correct. So okay, we are getting this, no? So the next one we have to do is again convert this mass basis, no, into its volumetric basis. So we have we have five compounds. So what do we do is we can convert this into its volumetric, no, to find the total volume, no, in kilomoles. So we have N total. We have the N of CO2 plus N of O2 plus N of N2 plus N of H2O plus N of SO2, no? So what we are going to do here, we can just divide them from their molecular weights, no? So this will be 3.128. So the molecular weight of CO2 is 44 plus oxygen. So oxygen is 0.84. 89. Is that 89? I guess so, no? For 89 over 32 plus 14.13. And then this will be 28. So 14 times 2 plus H2O. This will be 1.269 over, so 2 plus 16. So this will be 8. And then for sulfur dioxide, we have 0.01. And then you have 64. So the total number of molecules per kilogram of fuel, or kilomole, K kilomole, no? Kilomole. So 3.12. Actually, so yeah, I'll just write this down. 1, 2, 8, 44, 0.8489, 32 plus 14.13, 28 plus 1.269, 18. Then plus 0.01 all over 64. So the final answer for the number of kilomole per kilogram of fuel of the byproducts, no? So 0.6729, no? Kilomole of products, no, of the flue gas that is wet per kilogram of fuel. Okay. So this is not yet the final answer, no? We want to find the partial pressure. So therefore, to find the partial pressure of H2O, that will be the number of molecules of H2O versus the total, no, number of molecules times the pressure, or the total pressure of the flue gas. So we have the pressure of the flue gas, so P of the flue gas. So we are assuming that this is wet, no? Usually it is wet. No? So H2O here is this, no? So you have 14.13 all over 28 divided by total, so 0.6729, and then multiplied by the total pressure, no? So we can analyze the units here. This will be kilomole per kilogram, kilomole per kilogram. Everything will cancel out. No? So the answer should be, so 14.13 over 20, 28. Oh, this is not 28. Sorry. This is N2 pala to, no? No, 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 no. Why did I erase that? This one, no? This one should be 18. No? So 1.269. Okay. So 1.269 all over 18. Then you have 0.6729. So the answer is, sorry, multiplied by 170. So the partial pressure is 17.81. 17.81 kilopascals. So you can convert this into its dew point. No? You can find the dew point temperature using your table 1. Okay, that's it.